So in this next video, we're going to talk about the differences between speed and velocity. And we're going to use some of the definitions from the last video on scalars and vectors to help us define speed and velocity. So in everyday life, the terms speed and velocity are used almost interchangeably. But in physics, they're very different things. All right, so first let's talk about speed. So let's say I tell you that I'm in my car and I travel 50 miles and it takes me an hour. So my speed is 50 miles per hour. So I could write it like 50 mph, or I can say 50 miles over hour. Okay. So my units are always some measure of distance over some amount of time. So I could say from here that speed equals distance over time. And that should make sense because, again, 50 miles per hour. So miles is a way to measure distance, and hours is a way to measure time. Now, if I'm in my car and I'm traveling at 50 miles per hour, it's, very unlikely that I maintain that speed for the full hour. I might have to speed up or slow down. So if my speed odometer says, oh, I'm at 50 miles per hour, that's my instantaneous speed. That's the speed that I have at that moment in time. But I might have, my car might be moving at a whole bunch of different speeds for that whole hour. So maybe my speed looks something like this. And this is a speed versus time graph. Okay, so let's say that this is 50. And maybe I'm, starting at 50, and then I've got to speed up, and then I have to slow down, and then I end up back around 50, and I fluctuate. But my average speed is about 50 miles per hour. So I speed up and slow down, and it all kind of takes care of itself and averages out to 50 miles per hour. So really, when we're using the formula distance over time, we're finding average speed. And that's, in more like concrete terms, speed, put it on the next slide, is total distance covered over time. Alright, so you might now be saying, okay, that sounds a lot like velocity. And it is pretty similar to velocity, but with one exception. So velocity takes into consideration direction. So remember that things that take into consideration both magnitude and direction are vector quantities, and things that are just measured in terms of magnitude are scalar quantities. So speed is a scalar quantity, and velocity is a vector quantity. So let's look at an example. If I tell you that I am traveling at 50 miles per hour west, that's my velocity. My speed, though, is 50 miles per hour. My direction is west. So scalars is just magnitude. A vector is magnitude with direction. So, speed is just magnitude. For example, 50 miles per hour. Velocity is the magnitude with direction. So, for example, 50 miles per hour west, or really any other direction. Okay, so the formula for velocity is slightly different than for speed. So because velocity takes into consideration direction, and remember from the last video that displacement also takes into consideration direction, velocity is therefore displacement over time. Okay, in comparison to speed, which is direction over time. And remember that displacement can be symbolized as delta x, and we're really talking about change in time, so that's delta t. Okay. Now let's talk about one other sort of interesting situation. Let's say that I am traveling along a track, driving in my car, and let's say my car maintains a constant speed of 20 miles per hour along the track. So it doesn't, slow up or speed up or slow down. It just stays at 20 miles per hour. So we know that the speed is constant. But notice that it's going around the track. So here's, my car, and then there it is again, and then it's over here, and then it's over here. So, at one point it's facing this way, then it's going that way, that way, that way, that way. So the direction is changing all the way around the track. All the way around my direction is changing. So my speed is constant, but my velocity is not, because velocity is speed with direction. So even if the magnitude is constant, even if my speed stays at 20 miles per hour, the direction is not constant. And to have constant velocity, both the magnitude and direction must be constant. In short, if either speed or direction or both are changing, then velocity is not constant. And that kind of will segue us into the next video, which talks about acceleration.